Good morning. In this class, we discuss a concept in C++ called function overloading. We know that we can define user-defined functions in a program or in a class which will be solving any tasks or problems as required by a programmer. So in a program, we can write a number of these functions. In C++, we have the property of polymorphism, and this can be achieved using the concept of function overloading and operator overloading. We shall see what are the details of this function overloading. Function overloading means two or more functions having the same name but differ in the number of arguments or the data type of arguments. That means it is the process of defining the same function to carry out similar type of activities but with the different data items, either the number of data items or the type of data items. Now we shall see how to define and declare the overloaded functions in a program. The main factor in function overloading is the argument list in the function definition. If there are two functions having the same name and different type of arguments or different number of arguments, then the function overloading is automatically called or invoked by the compiler. So it is also known as the compile time polymorphism. For example, if you see here, there are three functions declared: int sum, int a, int b. Two arguments are a and b, both are integers. In the second declaration, float sum, floatium, floatium. There are two arguments, both are floats. The third declaration is int sum, int a, int b, int c. There are three arguments, both all are integers. So in the three declarations, we observe that the function name is same, that is sum. The number or the type of arguments are different in all the three functions. So these function declaration prototypes indicate that these are the overloaded functions. That is, the same function sum is overloaded or defined in three different varieties. You observe here in the definitions or declarations that the return type is different for three declarations. Each overloaded function must be declared and defined separately. Here I have two declarations of the function sum and corresponding two definitions. So when you look at the slide, you can understand that in the first definition there are three integers p, q and r which are added, and the sum of these three values or parameters is found out and displayed. In the second definition, the same function sum takes two floating point values as arguments, and the sum is calculated. So the same function name acting differently at different situations. In this example program, you see how to compute the area of a triangle, a circle and a rectangle is done using the same function name area but defined in three different ways. So this becomes a simple example of function overloading. Let us see some advantages of the function overloading or the need of function overloading. First one, that the code is executed faster comparatively, and it is easier to understand the flow of information and debug because similar activities are done. Function name remains the same. Code maintenance is easy, and it is easier to interface between programs and the real world objects. Now, following are the restrictions on overloaded functions. First thing, we know that each function in a set of overloaded functions must have different argument list. Then second point is the type def, which you know that it can be used to create another name for data types. This is used for naming functions. Then the function is not considered as different type because the new name given to a basic data type using type def becomes the one and the same. That is why it is not to be considered when you use typed. The third point is the difference only in the return type of a function is not to be considered for overloaded functions. So two function declarations or definitions having only the difference between their return data type is not to be taken as overloaded functions. Now let us discuss about another type of special function in C++, that is called inline function. An inline function is a special type of a function whose body is inserted at the place where it is called. That is, instead of transferring the control, which is done normally in usual normal general functions, compiler replaces the function call with the function body. So here there is no overhead of transferring the control to the place where it is defined. The keyword inline is used to define inline functions. Following are some of the rules in defining inline functions. The inline function definition starts with the keyword inline. The inline function should be defined before all the functions that call this inline function. The compiler replaces the function call statement with the function code, the body, and this process is called expansion. And then the compiler compiles the entire code. Here is the syntax of defining an inline function. Inline, return type, function name, argument list in the parenthesis. Next, the statements of the function, and the last one is the return statement. Here the keyword inline is to be used in the header line statement at the beginning of the definition. The following program explains the inline functions. Now let us find some advantages and disadvantages of inline functions. Advantages. The size of the object code is considerably reduced. The speed of execution of a program increases. Very efficient code can be generated. There is no burden on the system for function calling. That means the overhead is reduced. It is also saving the overhead of return call from a function. The readability of the program increases. And the disadvantages also displayed here. Now let us discuss another type of special function in C++, that is called a friend function. A friend function is a non-member function of a class which has the access permission to the private and the protected members of a class. That means we can access the private as well as protected members which are otherwise not accessible, but using a friend function we can access those. It is a non-member function of a class. The friend function is declared within a class using the prefix friend, which is the keyword, but it should be defined outside the class like a normal function without the prefix friend. Here are the properties of friend functions. A friend function is a non-member function of a class which has full access permission to private and protected members of a class. It can be declared either in the public or private part of the class. Of course, it can be declared anywhere inside the class. A friend function cannot be called using the object of that class, but it can be invoked like any other normal function. The function is declared using the keyword friend, but while defining the function, friend keyword should not be used. They are normal external functions that are given special access privileges. It cannot access the data member variables directly and has to use an object name dot member name format. The use of friend function is rare since it violates the rules of encapsulation and data hiding. This is the syntax of declaring and defining a friend function, and the following example illustrates friend function usage. Hope you have understood the concepts in this chapter about function overloading, then inline functions and friend functions. Thank you.